Recently, I have placed an order with the Australian filament manufacturer, Aurarum Proprietary Limited, for some more PLA+, as I was running out of a couple of colors, and I was offered a couple of normal PLA filaments to test out, so I asked for a roll of black and a roll of white. I have mainly been 3D printing PLA+, as it has the characteristics I require, and I have tended to neglect the normal PLA, so this has given me the opportunity to do some testing and experimentation with normal PLA filament. I have done a modification on my Ender 3 Max 3D printer by replacing the original Creality heat break with a Slice Engineering copper titanium heat break, which better separates the heater block from the filament input and heatsink. The Slice Engineering heat break isolates the Teflon Bowden tube from the heater block, which improves the filament feed to the hot end and allows higher printing temperatures to be used, if that is required. If you are into IKEA-style decor, Aurarum High Gloss White PLA is a very good choice, as you can print attractive pure white components that can be used in a domestic environment, where the component is not subject to elevated temperatures, and correct design of the components can ensure they are strong enough. The recommended printing temperature for the white Aurarum PLA is 185 to 220 degrees, and in this first test, the nozzle temperature is set at 220 degrees with the heated bed at 65 degrees and the feed rate at 70 mm per second. The 5-line skirt is for a reason. It fully purges any other color in the nozzle, and it gives you a very good look at how your first layer is printed. For a little over 1 hour printing, this is the end result, a simple strong fitting with good layer bonding. A center finder, downloaded from Thingiverse, is a good target for white Aurarum PLA, as it is hard enough and easily strong enough for normal use. This handle is printed in black Aurarum PLA+, and it is normally used in this context, but it can also be printed in Aurarum white PLA, if it is sliced with the intention of making it strong enough. With the white Aurarum PLA loaded, the white handle is being printed, while ensuring that the bottom layer is properly bonded to the bed, so that you get a reliable print. The nozzle temperature is set to 220 degrees with the heated bed set to 65 degrees. If the mounting faces are sanded flat, and high-quality fasteners are used to mount the handle on a flat surface, this white handle is more than strong enough in most instances. Not all 3D printing is industrial or structural. This is a test piece for the Ender 3 Max for printing a tall hollow model. It was printed in a gold PLA Plus at 215 degrees for the nozzle and 65 degrees for the heated bed. Once finished, it was not all that useful, so I cut it down and turned it into a container for decluttering my work area. This black PLA handle was printed at 225 degrees to test layer adhesion. With the following images, anything under a microscope looks terrible, but it's a viable method of getting a close look at the layering of a 3D print. This image, taken from the underside of the handle, shows that between the layers, there is a fused area, which means the adhesion between the layers is sound, which produces a high-quality, strong 3D print. The radiused edge of the handle shows what the final pass of the print looks like. Some slices have the option of ironing, but it has been my experience that you get ugly blotching on an area of this size, and generally you get a better appearance by sticking to the original final pass appearance. The following are a set of tests, done with Aurarum Black Gloss PLA, at different temperatures ranging from 220 degrees to 230 degrees. The tests are to determine if there are any advantages in going over the specified maximum temperature of 220 degrees. The first test is printed at 230 degrees, and while the example is structurally sound, it is starting to show some appearance deterioration, due to being printed over the specified temperature. An attempt was made to improve the appearance by running the slicer option of ironing, but the results made it look even worse, with an ugly blurred look, so that particular approach was abandoned. Dropping the temperature back to 225 degrees produced a noticeable improvement in appearance, with minimal printing artifacts, so this is a viable option for items that must look okay. Printing at 220 degrees produces the best appearance, and by observation while printing, the interlayer bonding is sound, so unless you are addressing a problem, staying within the specified range makes sense. PLA is one of the strongest filaments you can use with most 3D printers, But its downside is it is not a flexible filament, but the solution is simple. In most practical applications, just make it stronger with your slicer settings. This example uses 5 lines for any outside edges, which greatly increases its strength, and with the mounting holes having the same line count from top to bottom, screws that mount the example actually make it stronger. The other adjustable factor is the infill percentage, and while it is not as important as the outside lines, an infill between 25 and 50% is a reasonable ratio to increase the strength of the example. What is the takeaway from a set of tests like this? The examples have printed faultlessly, and with a temperature tolerance range that exceeds the original specification. The interlayer bonding has been very good at a different range of temperatures, and the examples are easily strong enough for their intended use. Have you experienced the never-ending wait for goods languishing on the high seas, on a container ship, without a clear knowledge of even if the items have been sent? Then there is the delays getting items through customs, and if you are lucky, the goods will get delivered in your lifetime, if they get delivered at all. There is a solution: buy Australian from an Australian manufacturer, and have it arrive in a couple of days.